Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Annelin Sindane. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Our lesson for today is statistics and regression analysis. We have to revise statistics so that we are able to get all the marks, the easy topic in paper 2. Now, I will just quickly show you the weighting of our paper 2. We have statistics, which has between 17 and 23 marks, which is our topic for today. We have analytical geometry. We are going to be doing analytical geometry next week. It has between 37 and 43 marks. We have trigonometry. It has between 47 and 53 marks, and we have Euclidean geometry that has between 37 and 43 marks in our paper, 4 topics, and we are able to pass. Now, moving forward, we have to set our goals so that we know what we are working for and how we are going to achieve the marks that we need to get. Remember, if you are setting a target, you must be knowing that for each question, if your target is 80%, it means for each question you must get a minimum of 80 so that you reach your target. So we are saying if we just need a pass in order to get 45%, we must get 12 in statistics. And for a bachelor pass, we must get a minimum of 15. But I'll encourage you to get a maximum. The others you are able to see, I will not talk about them today. This is our information page that we normally use. We are able to see that one, our information sheet. Now, that's our information sheet. Now, our lesson objectives for today. Now, we have to differentiate between univariate and bivariate data analysis. Univariate means one variable statistics. Bi, it means 2 variables that you are analyzing. We have to determine the 5-number summary and use it to draw, interpret, and comment on the skewness of our box and whisker plot. We must be able to identify outliers. And in the given distribution, we must be able to draw and interpret an ogive and a histogram for continuous data. And remember, we are able to draw a box and whisker plot from an ogive, and you must practice that as well. Now, we also have to be able to draw a scatter plot, draw a line of best fit given a scatter plot, or when we have drawn a scatter plot, and we have to comment on the relationship that exists between the 2 variables. We have to determine the least squares regression equation and use it for prediction. We can refer to our grade 12 examination guidelines for 2021 on page 8. What is examinable for under statistics? We move on. Our pre-knowledge, we know how to calculate a mean, a mode, a median, standard deviation. We have known these bar graphs, histograms, pie charts, frequency polygons, frequency tables, stem and leaf diagrams, and we have done a bit on ogives and cumulative frequency graphs. Now, I'll just help you revise the theory that we must know under this. So statistics is also known as data handling, which is a process in which our data is in numerical form, is collected, recorded, represented, and analyzed. Now, so we know that data is facts and numerical information that is being analyzed. It can be grouped or ungrouped in this case. Ungrouped data, this is a set of random data elements gathered for analysis. We have written our prelim papers. We have analyzed and we have seen which topic do I have strengths, which topic I have weaknesses. So it means we are able to see where we stand right now, and we are able to plan ahead to see, for me to get this mark that I need, it means if I got 60%, I still have to get about 10% in order for me to get my 70% target. So that is the analysis that we need so that we are able to make informed decisions. For grouped data, these are data elements that are aggregated to different groups or classes or intervals for ease of analysis. We shall look at measures of central tendency. This is how we analyze the data. We have measures of central tendency, we have measures of dispersion that we use in order to analyze the data, and then we compare which one can we easily use to make a meaningful conclusion. So, measures of central tendency, this is when you have a single number around which all data elements seem to be spread. And under central tendency, we look at the mean, also known as the average, where we sum up our data elements and we divide them by the number of elements in the data set, which we use as n. And for our formula, we use x bar as a symbol for our mean, and we divide by the number of data elements. So summation sign of all the data elements. And then we have, for grouped data, we calculate an estimated mean. And to calculate an estimated mean, we use x bar estimate, which is given by the summation sign, frequency times the midpoint of each interval divided by the cumulative frequency. And where our f is the frequency and m is the midpoint of the class interval there. And then we have also a median, which is the middlemost data item when the data items are ordered. Now, to get its position, we use half n plus 1, where n is the number of data elements. So if there are 15, it means when we substitute there, it will be half of 15 plus 1, which is half of 16, which means position 8 will be our median position. Then we take the data item which is in position 8. Please let us be careful when we are calculating this. The mode is the most frequent data item in the data set. In other words, the data item that has the highest frequency. If we are having ungrouped data, for grouped data, it is the class interval that has the highest frequency. Now, we move on now to measures of dispersion. Dispersion, spread, disperse. So it comes from there. We are looking at the spread of our data items. And we are saying, we look at the range where we are saying we have to order our data items or identify the smallest, the lowest data item in the data set, and the highest. The difference between the two will give us the spread. That gives us the range. Interquartile range, we must find the spread between the upper quartile and the lower quartile. The difference between the two will give us the interquartile range, abbreviated IQR. We move on. Standard deviation. This is a measure of how dispersed the data items are around the mean. And we know that there's a relationship between variance and standard deviation. Standard deviation is the square root of the variance. And if we square standard deviation, we get our variance, which is standard deviation squared. The quartiles, it's grouping of our data items into quarters in an ordered data set. And we have our lower quartile, which gives us the data items that lie below a quarter or below 25% of the data set. And then the position is given by 1/4 n plus 1. N is the number of data items in the data set. Hence, I said to you, we are also able to get our quartiles and our interquartile range from an ogive, because we can get these positions, our n becomes the cumulative frequency there. The upper quartile, these are the data items that are either greater than 75% or below 75%. So if they are greater, it's the 25% between 75 and 100%. The position is given by 3/4 times n plus 1. And then percentiles, here we are grouping our data items into percentages. In fact, we are putting them between position 1 and position 100 as we are grouping them. So if we want the 70th percentile, it means it will be 70 over 100 times the number of data items that we are analyzing, and it gives us the data item in the 70th percentile. We move on now to the 5-number summary. I've already discussed the 5-number summary. We have our minimum, lower quartile, median, upper quartile, as well as our maximum value there. We use these to draw a box and whisker plot, and we are able to comment on the skewness of our data. If the mean is equal to the median, we say our data is symmetrical. And if our mean is greater than the median, our distribution is positively skewed or skewed to the right. If our mean is less than the median, then we say the distribution of the data is negatively skewed or skewed to the left. And then in any symmetrical distribution, we are saying 68% of the data items will fall within 1 standard deviation to the mean. And you will find, we must know this, and it's not given in our formula page. And we are saying approximately 95% of the data items will lie within 2 standard deviations to the mean, which is that interval there. Now, outliers, we are saying these are data items that are a lot bigger or a lot smaller than the rest of the data items in the data set. Now, for us to find the interval for our outliers, we are saying anything that is less than Q1 minus 1,5 times the interquartile range. So, in other words, other literature uses this formula, Q1 minus 3/2 IQR and Q3 plus 3/2 IQR. Anything that is outside this interval, it's an outlier. And from a scatter plot, you will find an outlier is the one that looks furthest from the rest of the items that you have plotted. So this and this is the same. It just gives us this. I've given it as an interval here. It's saying anything less than. There it's saying anything greater than. So we must be able to use that. Our ogive, which is our cumulative frequency curve, it has a letter S shape, and it's a smooth curve drawn by plotting the upper limits of the class intervals of a grouped data against the cumulative frequency of the data set. We were going to practice this. Grouped data, we are saying this is continuous data, and ungrouped data, we say it represents discontinuous data. A histogram, we know a histogram, it is similar to a bar graph, but there are no spaces between the bars. And the midpoint of a class interval is half the sum of the lower and the upper limit of the class interval. For example, if we have 10 less than or equal to x less than 20, for us to get the midpoint, you add the 10 and the 20, you divide them by 2, which means the midpoint will be 15 there. We move on. The frequency polygon, we join the midpoints. We plot the midpoints and then we join them using a straight line to give us a closed shape, and we call that a frequency polygon. Now, I have explained that the histogram, there are no gaps. The model class for grouped data, we get it by the class interval that has the highest frequency. And we are saying, I'm explaining how we draw the frequency polygon. Our ogive, it's also used to represent continuous data. These are the formulae from our formula page that we normally use for statistics. Please refer to your formula page so that you do not write wrong formulae. And again, we have to be in the statistics mode so that we are able to get all the variables that we need. Write them down as soon as you get a question paper. Do the analysis of your data, write everything that you can get from your calculator, write it down somewhere, then answer the questions. We move forward. Now, this is the question that we wrote for our prelim paper. Now, I will do the first part with you because I know you will not have the graph for you to plot the scatter plot. I'll demonstrate and then you will do where we need to do calculations. I'll demonstrate. We have a column for cumulative frequency which is not completed. It's either will be asked to complete or will have some values missing. When they have plotted a cumulative frequency graph, we're expected to get a frequency for a particular class interval. We must know how to do this. So because we are given the values, always we go straight, we write the first frequency is 3. To get the next cumulative frequency, it becomes 3. We add the 4, we get that as 7. 7 plus 13, it will give us 20. 20 plus 20, it gives us 40. 40 plus 21, it will give us 61. Plus 12, it will give us 73. Plus 12 again, it gives us 85. Plus 8, it will give us 93. Plus 5, it gives us 98. And then it gives us 100 as our cumulative frequency there. So it means when we are expected to plot our scatter plot, we must identify the points that we are going to plot on our graph. Remember? So the first point, it is going to be 10 and 3. We will have the next one, our upper limit here, it's 20. And our cumulative frequency is 7. The next interval, we are going to have 30. And our cumulative frequency is going to be 20. 40 and 40 and so on and so on. And the last point that we are going to plot there is going to be 100 rand and a cumulative frequency of 100. But remember, we have to ground our cumulative frequency graph. So in this case, when our minimum here is 100, so our minimum is 0, so we will have a point with coordinates 0 and our y value there will be 0. We always have to ground our cumulative frequency graph. So then these are the points that we are going to plot. 10 and 3 will be somewhere there. 20 and 7 will be somewhere below 10 there. And then we have 30 and 20, it will be somewhere there and so on. But remember, we must have the grounding 0, 0, and our last point will be 100. We join these points using freehand, and our graph would look something like this. Now, so when we mark this, it's 4 marks. When you are plotting the cumulative frequency and a point in the correct positions for grounding, The shape, it must be a smooth curve. Please do not draw a broken line graph where you join 2 points at a time using a ruler. You will not get marks for the shape, and then you get marks for the shape there. We get our 4 marks. We move on now to 1.2. How do we use our graph to determine the number of employees that receive less than 35,000? Now, we use the cumulative frequency graph that we have drawn, in which case 35,000 will be between 30 and 40. Remember, this is in thousands. So you go to the midpoint there using your ruler up. When you reach the graph, you use your ruler again, you take your reading this side. And if you check, when using this graph, this will give us 30 employees. But when we mark, we accept a range of values, anything between 29 and 31, you will get full marks there. Remember, when you are drawing your graph, it must be a smooth curve and it mustn't be zigzag. It must go straight, a smooth curve. And we are saying, indicate on your graph where you are taking your reading. Do not just write values without showing where you took them from on your graph. It has to be shown. And then we have to determine the median for the data. What is a median? In this case, we will say half. Our cumulative frequency is 100. So for this one, our position is going to be half of 100. You can use 100 plus 1 and 100 because it will give us 50,5. And it's so difficult for you to plot 50,5. So the safest way, you round down to 50. Again, you go that way. Where you reach your graph, you come down to give the reading. So you are taking your reading from there. That's our Q2. And in this case, our Q2 will be around 45,000 and we'll accept 44,000, 45,000 and 46,000. We move on to question 1.4. For question 1.4, I will give you 3 minutes to work out the mean and the standard deviation. Please always read the information in full. Your 3 minutes start now. Welcome back. Now, it is important that we read the statement in full. We are told that the monthly salaries of 5 employees in the given interval are those ones. But let's not make a mistake of not reading the rest of the information that is given there. We are told that 2 employees from the interval 70,000, between 70,000 and 80,000 are promoted to receive monthly salaries. So it means these ones, they are moving from the interval of 70,000 to the interval between 80,000 and 90,000. So it means when we're analyzing this data, we are having 83,000 as one salary. We also have another salary of 84,000. In other words, we are now analyzing 7 data items instead of analyzing 5. So remember, how do we get a mean? We sum up the data items, we divide them by the number, which is 7, and this should give us a sum of 80. It should give us a mean of 85,857.14. If you used 5 data items, this is an accuracy mark, it's only 1 mark. You will not benefit because it's not an accurate. You did not read properly the question there. Calculate the standard deviation for this interval. You will find you are just using your calculator to get your standard deviation, which is 2,294.63. The next question, we have to determine the percentage of employees whose monthly salary lie within 1 standard deviation of the mean. So to do this one, remember we have calculated our mean, we have calculated our standard deviation. We must get our interval first. Mean minus standard deviation, mean plus standard deviation, we substitute and we should get our interval to be between 83,562.51 and the upper limit is 88,151.77 rands. So any data item that falls between will be counted. So we will have this 84,000, 2 of them. We'll also have 85,000 and we'll also have 87,000. So we have 1, 2, 3, 4 salaries that fall within the given interval. So, and then we convert this to a percentage because our total number of data items are 7, so it's 4 over 7 times 100%, and this will give us our 3 marks there. Now, here's an activity that I would want us to quickly answer. I will give you 7 minutes to answer question 1.1, 1.2, 1.3, 1.4, and 1.5. We should be able to answer our 7 minutes start now. Welcome back. I hope you were able to do the completion of that table. Now, as you can see, this is about 3 marks. So for each of the given columns there, you must complete it in full for you to get the 3 marks. So this is a sample of residents who were asked how many liters of water they used per week, and the results were summarized in the table. We have to complete the table, so I have provided the grid so that you are able to complete there. So in order for you to complete, remember the frequency they've given us. I have demonstrated how we get our cumulative frequency. So for us to get the midpoint of the first interval, we said we add, so it will be 50 plus 100. We divide this by 2, and this will give us 150 divided by 2, it's 75. So the midpoint will be 75. Our frequency is going to be 20, and 75 times 20 should give us 1,500. You move on to the next interval, you do the same thing. And our completed table should look something like this. So for each column completed correctly, it's a mark, it's a mark, it's a mark. And you will realize that this is going to help you answer question 1.2. We have to calculate the estimated mean. Remember, in order for us to calculate the estimated mean, we should use our X bar. We said it will be our 20 times the midpoint, 20 times 75 plus. The last one, it's going to be 375 times 50. That is the last one, 375 times 50. We all divide this by the cumulative frequency, in which case our cumulative frequency is 400, then we are able to get. So the table has made life easy for us because our total sum there is 100,000, and we are dividing the 100,000 by 400, and we get this as 250 liters as our estimated mean. Answer only, you will get your 2 marks there. We have to draw an ogive because we already have our cumulative frequency. We are plotting the upper limit and the cumulative frequency, upper limit, cumulative frequency. Then we are able to come up with an ogive which would look something like that. Now, remember, it has to be a smooth curve, and remember, it shouldn't go beyond. It should start at 50 because our minimum there is 50 for the interval. So on the previous one, remember we had a 0, 0. On this one, we can't have a 0, 0. Let's move on. We use the ogive to determine the median of the data, and we are saying the median for the data, it's going to be half of 400, which is our cumulative frequency. So position number 200 will give us the median, our Q2. As indicated there is our dotted line. Then our median is going to be 250 liters. We have to comment on the skewness of the data, and we give a reason for the answer. Now, remember, for us to comment, we compare the mean and the median. If you check, our mean was 250 liters. Our median is also 250 liters. So the mean is equal to the median. Therefore, we say our data is symmetrical, and our reason, the mean is equal to the median. So we get our 2 marks there. Now, we are told that the municipality introduced restrictions there on the usage of water due to water shortages, and the residents may not use more than 300 liters of water per household per week. How will this affect the standard deviation? Now, if you check, because our maximum is now 300 liters, so it means our mean is going to be less, therefore the standard deviation will become bigger, and the values of the water usage there will be further from the new mean, hence the standard deviation will increase. Now we move on to scatter plots, analysis of our bivariate data, and we are saying we are using correlation, which is a measure that expresses the relationship between the two random variables. We use a scatter plot where we plot one variable on the x-axis and the other one on the y-axis, dependent, independent variables. And we use the least squares regression line equation, which is given in that form. A is our y-intercept and B is the gradient of the line. And we know that our least squares regression line always passes through the mean for the x values and the mean for the y values. We plot that point, and then we have our y-intercept. We join the 2 points in order to get our line of best fit. So we use a correlation coefficient, which is R, is the numerical measure of the type of relationship between the two random variables. And the least squares regression is the one that is used to get the line of best fit. And we have 3 types of our correlation trends, in which case we will focus on the linear one because that's what we are busy with now. The other 2, we have a quadratic, we also have exponential. We will study these as you pursue your statistics, but for our purposes we only concentrate on the linear trend, but you must be knowing that we have got other trends for the correlation. It's not only linear. Now we know that our relationship can either be positive or negative, or it can be non-linear. If it's positive, you will see the points will more or less like be increasing. The points can be decreasing if it's a negative correlation, and if the points are just all over, you can't even draw a line of best fit. We say there's no correlation there. Now, our correlation coefficient R is a numerical value between -1 and 1, and we need to comment on the strength of the relationship. And if the points are closely packed, you will find that in most cases, if they are strongly packed and it's increasing, it's a strong positive correlation. If they are not close together, we will say the correlation can be fair or moderate correlation there. Now, we use this scale to determine our correlation coefficient so that you are able to comment. If it's -1, it's important to just say it's the strength and the sign. Strong positive, strong negative. If you just say strong without the negative, sometimes you might not even get the mark, because we always have to talk about the sign, whether it's a positive or a negative correlation. If it's weak, we also have it's a weak negative, weak positive, and so on and so on. Now, this is just a reminder. We plot a line of best fit, and we have also indicated that it has to pass through the mean, and we know that we get our y-intercept from our equation. Substitute x as 0, then it will give us that. Now we are able to draw a line of best fit, and remember, our line of best fit must be plotted from the minimum x value to the maximum x value. Anything outside that, we are extrapolating, and we cannot trust our extrapolation there. We only trust our interpolation. So extrapolation, where we just estimate. It can be greater than or less than the minimum, but it cannot be trusted because our line of best fit does not always go beyond the data set that we are analyzing there. Now, we had this question for our prelim paper. I would give you 5 minutes to determine the least squares regression line and answer those questions. 5 minutes, start now. Welcome back. I hope you were able to use your calculators to determine that information. So what we need to do sometimes, as you can see on the table, it's not indicated which one is X, which one is Y, but because the scatter plot is drawn, you are able to now see which one is on the X-axis and which one is on the Y-axis, and then you are able to do that. But also you are able to see that the amount spent depends on the number of customers. So now you are going to get from your calculators, we got our A as 12.59 and our B we got it as 7.329 and so on. Two decimal places, this will give us 12.60 plus 17.33x. So the value of A, the value of B, and for the equation. I'll always encourage you to always write down the value of A, the value of B, and the equation to predict the money spent by 11 customers. You are going to substitute our X value as 11, you get a mark, and you're going to get your answer as that. And when you use the values without rounding off, you should get the answer. It's also accepted there. The correlation coefficient for the data, we are using your calculator and we should get our R as 0.95 to 2 decimal places. We get our 1 mark there. We move forward. You are told that the organizers of the event think that there was a very weak positive correlation between the number of customers and the amount of money received at stalls. Motivate whether you agree or not. What would you say? The previous question is guiding us. If you check, our R is equal to 0.95. This is a strong positive correlation. So these are saying it's a very weak positive. So will you agree? I will not agree. So the answer will be I will not agree because, let me quickly go back. Sorry about that. Right. I will not agree, and to motivate my answer, it's because 0.95 is a strong positive correlation. And then we are told that at another stall, 6 customers spent a total of 195 rand. If this point is included in the data, will the gradient of the least squares regression line increase or decrease? Now, the gradient will decrease because this point with coordinates 6 and 195 is further from the data set. They are saying without further calculations, but if you're using the least squares regression, you are able to see that this, if you substitute 6 there, it will give us something around 116 rand. So it means this point becomes an outlier, is very far from the regression line. Therefore, the gradient will decrease or it will become less steep because this point is far from the other points that we are having, or you can just say it's an outlier. We move forward. Here is an activity that I would want us to answer. I will give you 4 minutes to answer that question 2.1 and 2.2. Welcome back again. For this one, I hope you are able to see that it's easier now because we are given the X and we are given the Y, but please let's make sure that we check our data as we capture it in our calculators. Now, we are able to determine the equation of the least squares regression line. From our calculators, we got our A as 0,047807 our B is 0,006770004. Now, our equation to two decimal places becomes y is equal to 0,05 plus 0,01x. Value of A, value of B, and the equation. We have to use the regression line to predict the leg strength of an 18-year-old ball if he does 110 leg presses. So the strength, we substitute 110 and we get 1,15. If we use the original equation, this will give us 0,79 as the answer. Substitution, answer there. So we get our answer there. Now, we are told that an 18-year-old boy does 250 leg presses per day. Can your regression line formula predict the strength of his legs? Explain your answer. That's where the theory comes in. If you check for our x values, 250 is outside. So it means we can't use our least squares regression equation to predict because this becomes extrapolation. And we said for extrapolation, we cannot trust as our line of best fit or our regression line equation cannot be trusted there. So we are going to say no because this is extrapolation. We have to calculate the correlation coefficient of the above data set. I know you wrote this one down as you did your, and we found our R as 0,97. And we are supposed to use the answer in question 2.4 to describe the relationship between the number of leg presses and the strength of an 18-year-old boy. And we found out that this will be, in other words, you are just commenting. Our R is 0,97. This is a very strong positive correlation between the two quantities. So, for you to get an answer there, for positive and for strong correlation, you get your 2 marks there. Now, I will give you this activity. I will give you 9 minutes to answer those questions. these questions. These are the number of liters of diesel purchased by 15 truck drivers. You are able to see that. I've arranged them in ascending order so that I'm able to quickly analyze. The mode, if you check, 88 has the highest frequency, so I'll say our mode is equal to 88 liters. The range, our maximum, so 1 mark there, range will be equal to 98 minus 41, and that gives us our answer as 57 liters. The mean, we sum up all the data items and our mean, we get 1104. We divide this by 15 and this will give us 73.6 liters. The standard deviation, we get our standard deviation as 16.3 liters from the calculator. So here we are getting our 2 marks, and there we got our 1 mark. Here we get our 1 mark. Determine how many truck drivers purchased liters of diesel below 1 standard deviation to the mean. So remember, below it's x bar minus standard deviation. You can use that, which will give us 73.6 minus 16.3. Anything which is less than, it's below, and this gave us our answer there as 76.3 minus, it's comma 6 minus 16.3, and that will give us 60.3 as the minimum. It's 73.6 minus 16.3, and this will give us 57.3, 57.3. Anything which is less than 57.3, you go to your data. Anything that is less than 57.3, so it will be 1, 2, 3. So therefore, we get 3 drivers. So you'll get a mark for the method, getting your 57.3 and getting your 3 drivers. There we get our 3 marks. The next question, it's analysis of our data using the mean weight. We are told that these are going into a lift. The mean weight of 8 people entering into a lift is 75 kgs. The lift has a weight limit of 1000 kgs. How many people can still get into the lift, assuming that the mean weight remains as 75? So in other words, you will have to do the following. So we are saying x, we find this sum divided by 8. This will give us 75 kgs, which means the sum of the weight of these will be 8 times 75, giving us 600 kgs. Now we are told that the weight limit is 1000 kgs, so we have to find the difference. So we have to find the weight, which will give us 1000 kgs minus 600 kgs, and this will give us 400 kgs. So now to get the number of people, which is n, it becomes 400 kgs divided by 75 kgs, and this will give us 5.3333, which means therefore 5 more people can go into the lift. I like this question because it's an application question. Now, because of time, I'll ask you to take a picture of this question, and it does not need a graph, but you are able to do the calculations there. Now, Here is the question. Let's work on the questions later on, and we should be able to answer those 5 questions, 2.1 up to 2.5. That's our activity 4. Now I will move on. I'll quickly show you the solutions. So it's a strong negative because our R is going to be negative 0.97. You get your 2 marks there. We move on to the next part. Our A will be 104.8 and our B will be negative 3.82, and that's our equation. We get our 3 marks there. Now, the number of heaters, when the temperature is 20 degrees, we substitute for 20 and we get 28.4, which gives us 28 heaters. Now, 2.5, we are supposed to draw a line of base fit on the scatter plot, and it has to pass through the mean for our x values and the mean for our y values. The standard deviation, we get it from our calculators, and it will be 34.13. Now, in summary, we have to perform calculations of measures of central tendency to solve statistical problems. So we use central tendency and measures of dispersion. We must be able to determine the 5-number summary and use it to plot a box and whisker plot that we should be able to comment on the skewness. We have to plot and interpret our ogives, and we use them also to determine information like our box and whisker plot. We must be able to use statistical summaries, which is our measures of central tendency and dispersion, and graphs to analyze and make meaningful comments in the context associated with the given data. Now, the scatter plot is used to analyze 2-variable statistic, and we must be able to use the correlation coefficient to determine the strength of the relationship between the 2 variables. Please, let's keep on practicing, and I wish you all the best. We are going to pass mathematics. Have a good day and practice well further. Goodbye.